I'm just going to do a review of what we've done recently. And we've spoken about grouped data recently and how grouped data will often occur in tables where we'll have like intervals over here. So maybe let's go from 0 to 10, 11 to 20, 21 to 30, 31 to 40, 41 to 50. And when we have the interval, we'll often have a frequency column that goes with that. And so maybe we'd have something like that. And in addition to this, we need to know how to do something called the cumulative frequency column. And the way we add up the columns in the frequency thing, and we go from there. So if we look at this one, the cumulative frequency in row 1 would be 1, then it would be 3, then it would be 8, 14, and in this case, 22. And so the total for the frequency column would also be 22, and that's how many students we have in the data set, or however many items we have. Give me a thumbs up if you understand how that sort of table works with grouped data. So the first part of this course was about lists of data, but now we're working more and more with group data in tables. And sometimes we also have to find the midpoint. And we spoke quite a lot about this in the last lesson, the midpoint of an interval. And that can be useful when we're working various things out. Then we spoke about what are the graphs of grouped data, and we did something called a histogram. And then we did something called a frequency polygon, which basically describes the data in a table. And then today we are going to talk about an ogive, or sometimes called a cumulative frequency curve. And just to remind you how these graphs work, a histogram has frequency on the vertical axis, and then it has intervals going along like this, and you'll see sort of bar-like categories or figures over here. And there's no gaps in a histogram because you have continuous data. If you want a frequency polygon, you just add 2 intervals on each side. You find the middle of the interval for each interval, and you go in line with the frequency, and then you connect them using straight lines, and that will give you your frequency polygon. Now the ogive is all about comparing, is basically with showing the cumulative frequency column against the intervals. And so that's what we're going to talk about today. Give me a thumbs up if you followed all of that or it looked familiar. Give me a thumbs down if I've lost you in any way. I'll just give a moment for everyone to give the thumbs. Atlicham, I see that thumb. Has anybody else got a thumb for me? And Takeni, can I see that thumb? Are you with me? There we go. Let the thumbs do the talking. Awesome. Okay, so let's talk about an ogive, or a cumulative frequency curve. Big fancy word. What does it actually show? Well, it shows the information from a cumulative frequency table. And what do we use it for? We use it to estimate the median and the interquartile range of grouped data. So in previous sessions, I often gave you like a list of data, right? And then you could work out what Q1, Q2, Q3 was. If the data is in a table, we don't have the exact items, and so we need to estimate them. And that's what the ogive is going to be useful for. But things that we have to remember are, when we draw a cumulative frequency curve, the cumulative frequencies are plotted at the upper limit of the interval. Now that sounds like a mouthful, but all that means is that when you've got an interval, you choose the end of that interval to be the x value, and then you choose the cumulative frequency to be the y value. And it'll be easier if I show you an example. So here is a grouped data table, and this table is showing how long it takes for learners to get to school. I'm sure we can all relate. So 4 people are rather lucky. They take between 0 and 10 minutes. Aren't they lucky? Some are between 10 and 20. So 12 are between 10 and 20, and so on. Now, if I want to draw an ogive, I have to complete the cumulative frequency column. So I'm going to give you a minute to do that yourself, and then I want you to say done when you are done doing that. And while you're working out the cumulative frequency column, welcome to Atlachang, Kilabuhile, Ntakeni, Onelena, Selekane, and Siemtanda. It is good to be with you. I want to salute you for your hard work. It does take discipline, but your discipline will pay off. I'll give you a hint. The very first row has a 4. What do we think the next column is going to be? Okay. And that's going to be a 16. And then what's this going to be? Well, we add 20 is 36. Then we're going to get 44. It feels like we're just adding these up. Maybe you can help me. What's next? 32. Did you get 76? And then did you get 105? And then 120. And so that means that we have 120 students who are included in our data set. And if we added up the frequency column, we would get 120 as well. So now, how do I get the points that I put on my ogive? Now, they said that you need to use the end point of the interval. So all of these points are going to use the end point of the interval. So I'm going to have a 10, 20, 30, 40, 50, 60. And now what is going to be what's going to be the y value? Well, it's just going to be the cumulative frequency column. So you're going to get 4, 16, 44, 76, 105, 120. Now, in order to draw my ogive, I need to put this data on the table. And so I want you to draw this with me. So I've got my grid over here, and on the vertical axis, I'm going to have the cumulative frequency. Along here, I'm going to have the intervals of data, and I'm just going to go 10, 20, 30, 40, 50, 60, 70. How far do I have to go? Oh, I've gone far enough. 10, 50, 60, 70. And over here, I am also going to go, okay, I have to go up a bit more in this one. So let's go up in tens, but I need a bit more space. So I'll go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 100, 120. And I'll just put a couple of things in here. So 10, 50, is that 100? 100, 120. So we have got the graph set up. Now we have to take our points. Now, the very first point that I've got here is 10 and 4. So the dot is going to be there. But we do need to ground the ogive. So we're going to put in our own little point down here at 0. And then for the next one, we're going to get 20 and then 16, which is going to be about there. And the next one is 30 and then 44. So there's 40, 44 will be there. So I've plotted the first 3 points. Give me a thumbs up or a smiley face if you followed what I've done so far. Give me a smiley face, a happy face. Okay. Now, what I want you to do is I want you to plot the next 3 points on your own ogive, and then I want you to join them up using a curved line. So I'm going to get some water while you do this, but basically the next 3 points, you're going to plot them, and then we're going to join them using a curved line because it's called a cumulative frequency curve. And then at the bottom, I'm just going to say time in minutes. There we go. All right, over to you. I'll be back in a moment. So those are the dots or the points I have to connect. When you are done with this task, please just say done in the chat so I know that you are completed with plotting those 3 points, and then we'll move on to the next. So I'm going to start the process of joining up my dots, and it's a smooth curve. And so the smooth curve, oh, okay, it's going to look like that. Let me just make my dots a bit bigger so you can all see them. And what we notice is that the very last dot is in line with 120, which makes so much sense because that's how many students we have in our ogive. Okay. Now, are there any questions or comments about how to draw an ogive? The main thing that I'm remembering to kind of point out is you have cumulative frequency on the vertical axis. And when you do your points, you need to use the end of the interval. You also need to add a little point to the start. And when you draw it, it's not straight lines. It's going to be curved lines. It's a curved line. It looks a bit like an S shape. Give me a thumbs up if you feel like comfortable drawing an ogive based on this example. Okay, now part 2 of understanding the ogive is knowing how to estimate the median. So what we're going to do is when we estimate the median normally, what is always our first step when we estimate the median, when we have list data? What do we normally have to do when we're working out the median? You can put your hand up and tell me audibly. You can unmute yourself. We're a nice small group, so feel comfortable to do that. You can put it in the chat. What would you do if you were working out the median normally? I'm thinking back to earlier lessons, and I remember I always made you calculate the position of the median. Now, because this is grouped data, we don't know exactly what values we have, but we can use this curve to help us. What is the position formula for the median? What is the position formula for the median? Let me look in the chat. Who has some wisdom to share? I feel like Nsekeni or Atlechang. Oh, Atlechang, Elena, there we go. The wisdom is flowing. It's just going to be a half times n plus 1. Now, what is n? Well, n is 120. So what is the position, not the value, what's the position of my median? I think it is 60.5. So what I do is I go to the cumulative frequency axis, and let me use a different color. Where would 60.5 be? I think it would be about over here. Oh, sorry, my line must be straight. Let me try that again. So I'm going from 60.5, and I get here. Now, that is not the answer. But if I drop it down to here, that will give me an estimate for the median in minutes. So what do you think the estimate for the median should be based on where that thing is getting to? What would you call the estimate for the median here? What is the value of Q2 based on the visual of the cumulative frequency curve? Yeah, to me, it looks about 36. I agree. Maybe 36, 37, but you've got some leeway. So it's not a problem. You've got some leeway. So the estimate for the median is 36. What does that mean? That means on average, the median for this group of students is 36 minutes. Basically, the middle of the data is about 36 minutes to get to school. Now, using the same idea, I want you to work out an estimate for me of Q1 and Q3. So Q1 is the lower quartile and Q3 is the upper quartile. So we are trying to get estimates for those. But before we can get estimates for those, we need to find their position. So to speed things up a little bit, I will help you. To find the position of Q1, you use that position formula. To find the position of Q3, you use that position formula. Now, I want you to work out its position and then use the graph to get me estimates for Q1 and Q3. What have we got? 121. So that's 30.25. And that. So what is my estimate going to be for Q1? And what is my estimate going to be for Q3? Okay, so I'll look at the chat now to see what you guys, but hopefully you're seeing how I'm connecting the positions on the vertical axis to an estimate along the horizontal axis. So what does the chat have to say? So Atlikhang and Siamtanda are in the 26, 27, 28 zone. So if I look at Q1, that is the position 30.25, it looks to me like it's about 27. So 26, 27, 28 is all fine, but I'm going to go with 27 minutes. And then for Q3, I'm going to go with it being closer to 50. So let's say 50, if that's 40, looks about 56, 57. Let's go with 57. So those are my estimates. So it's 27 minutes, 57 minutes, 36 minutes. Now, I want you to work out an estimate for what's called the interquartile range. Can you remember what the interquartile range is? How can you use these estimates to help you find the interquartile range? Okay, so the question is, so why 57 for Q3? Okay, for Q3, give me a thumbs up, Atlikhang, if you agree that the position is 90.75. That's the position of the upper quartile. Okay, now let's go to the vertical axis. Can you see that this black line is in line with 90 almost? Then I draw a dotted line across, and then I drop straight down, and look at where it's landing. Oh my goodness. Everyone, I'm just making things up. Atlikhang has pointed this out. Thank you, Atlikhang. I clearly have lost the plot for a moment, because if that's 50, how can it be above that? This is going to have to be, if that's 40, that is about 46 or 47. In fact, I'm going to go with 46. Thank you so much, Atlikhang. Can we have a hand clap for Atlikhang? And some thumbs up from everyone who's hopefully less confused now. Amelia, Silikane, Onelena, and Takedi. There we go. Lots of hand claps. Very nicely done. So now that we have the correct Q3, can I please have everyone working out an estimate for the interquartile range? What do you think the interquartile range? I'll give you a hint. You're going to use Q1 and Q3. So the interquartile range is just Q3 minus Q1. So you go 46 minus 27, and it's going to be approximately, because it is an estimate, 19 units. Or 19, yeah. So the interquartile range is 19 minutes. And that's it. So what I've done here is, even though I didn't have a list of data, I've worked out an estimate for Q1, Q2, Q3, and I've worked out that the interquartile range is approximately 19 minutes. Okay, now, last question before we have a break. How many of the students in this table take longer than 46 minutes to get to school? So how many students, if you look at this graph that describes this table, how many students take longer than 46 minutes to get to school? It's a bit of a toughie, but I want to see, if you feel like you can do it, give a thumbs up. If you feel like, whoa, things got hectic, give a thumbs down. I will guide you, but I just want to give you a moment. So the question is, how many students take longer than 46 minutes to get to school? Give me a thumbs up or happy face if you can do it. Give me an unhappy face or a thumbs down if you're like, whoa. I have not seen anything like this in school. Please, Mr. Teacher Man, it's time for you to do some teaching here. Okay. So I said to you, how many students in total are there in this group? There are 120. Now, if I said, how many students take longer than 46 minutes? So let's go and find 46. Okay, well, 46 minutes is actually over here. It's the estimate of Q3. So if I follow this back from 46, what is this in line with? What is this in line with? Well, this is in line with about 91, isn't it? Give me a thumbs up because it's 90.75 actually, but we'll call it 91. Give me a thumbs up if you understand that 46 minutes maps to 91. I thought I saw one thumb there. Okay, now, if you know that 91 students take less than 46 minutes to go to school, how many students are left? So 91 take less than 46 minutes. How many are left in your total? I'll give you a little helping hand. These are the two values that are important. So if you want to work out how many students take longer than 46 minutes, all you need to do is go, well, there are 120 students in total. That's this value here. We know that 91 students take less than 46 minutes. So what is going to be left? And since I'm clearly a bit tired, I'm going to use my calculator. We get 29 students. Okay. Give me a happier face if you followed how I did. That was a tough question, but I want to make sure I show you all the types of questions. Give me a thumbs up or a happy face if you followed what I did there. Okay, this is good news. This is what learning looks like. All right. After that tough question, we all need a break. So let us go to standing up and just getting some blood flow and oxygen in our bodies so that we can continue. Okay, step one. Breathe in. Breathe out. Breathe in. Breathe out. Breathe in. Breathe out. Shake up our arms. Get them nice and loose. We want to be nice and relaxed so our brain is relaxed. Shake out our legs. And we're just going to do 15 jumping jacks to get the blood pumping in our body. So in 3, 2, 1, let's go. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and I am done. And while we are all catching our breath, I would like you to hit your favorite emoticon or, express yourself using an emoticon while I let my breath catch up. Oh, my heart is pumping. Ooh, I can really feel my heart moving. Ooh, okay. So let's go to a second example where you guys do a little bit more of the work here. So step one, I'm going to give you this data table. I want you to complete this data table, and then I want you to plot. So I'll add an extra column for the point to help you work it out. I want you to all complete this table now by yourself. And once you've got all the points, I want you to tell me done in the chat. And then after that, you are going to go and you are going to draw for me the ogive, or the cumulative frequency curve that relates to this. I'll give you one tip. We're going to start this at 90 because this starts at 90. But otherwise, you'll tell me done when you've finished with the table, and then I'll say something, and then you'll draw the ogive, and then we'll go from there. And what this is talking about, it's height. So if I look at the data, it's heights of students in a class. It probably is a grade 2 class or something, because I see the heights are quite small. But that's the context for the example. And I'm also going to put cumulative frequency here, and then I'm going to put intervals here. But yeah, fill out that column and then just let me know when you are. Okay. How are we going? Are we getting any dones there? Let's make sure sometimes, especially if you're tired, make sure you use your calculator. So 31 plus 28. Okay. Okay. 59, 80, 90. What do you think the points are going to look like that go with the cumulative frequency curve? So the thing that I wanted you to remember is that it's the end point that goes in the x value. So you are going to have, actually, let's use a different color. Let's use that. So it's going to be 95, 100, 105, 110, 115, 120. And going with that is going to be 5, 14, 31, 59, 80, 90. Give me a thumbs up if you are done getting those points and you get those points like I do. Now, what I want you to do is I want you to set up your axes and I want you to plot these points. But remember, there's one bonus point that you put in just at the beginning. but I want you to set up your table like I'm doing. I'm going to start with you and let's do it. So what do we go? 95, 100, 105, 120. That's it. And then for this, I'm going to go up 5, 10, 35. Oh, I should have actually gone up in tens there. So let's rather go up in tens. That scale won't work nicely. 10, 20, 30, 70, 80, 90. And that's as high as we need to go. And my very first point is going to be 95.5. But then I remember I have to ground the ogive. So there'll be 1 point there. And I will give you a bit more time to do the rest. One oh five, 31, 110, 59. Well, that jumped up quite a lot. 115, 80, 120, 90. So my data points look like that. But in order to get your ogive, you have to connect them with a curved line. And so you'll notice that in line with the last point is the value 90, because that is the total number of items in the data set. So next, what I want you to do is I want you to get me estimate values for Q1, Q2, and Q3. And in order to estimate those values, you are going to have to calculate the position of each of those. And then after you've calculated the position, you're going to have to use the graph to help you get your estimate. To make your life easier, I will give you the position formulas at the top, but you are going to have to work out what the actual position is and then get the estimates. So over to you. If you get stuck or you feel like I'm leaving you with too much to do, then I will watch the chat, or you can raise your hand to ask a question. Okay, 22.75. Let's find Q1 first. 22.75. What would my estimate for Q1 be? I think that looks like about 104. Give me a thumbs up if you would agree with my estimate of 104. And what is that? That's centimeters, 104 centimeters. for Q1? Give me a thumbs up or a happy face if you're with me. Okay, then over to you guys. I want to see some estimates in the chat. What are your estimates for Q2 and Q3? I'll choose red. Oh, that's not red. I'll choose red 45.5. And it's quite nice to actually put a Q2 there. What would your estimate for Q2 be? Who has an estimate for the median? What is the median? On Elena, what do you think? What would your estimate for the median be? What would, or I see you've actually just, oh, I think you're out of the room. That's Amelia, what do you think? What would you get for Q2? Atlakan? Yeah, I think it's about 107. It looks like it's between 105 and 110. Amelia agrees. Fantastic. What about Q3? 68.25. So that's going to be about here. To me, it looks about, I mean, I'd say it's about 112, 113, somewhere in that region. I mean, it's hard to know for sure. Let's round up to 113, but I totally am with you on 112 as well. Okay, now, next thing, what is the estimate of my interquartile range? What is the estimate of my interquartile range for this ogive? What is the estimate of my interquartile range? Well, first of all, I need to remember what the interquartile range even stands for. It's going to be that. But then Q3 is 113, Q1 is 104. So you are going to get about 9 centimeters as the interquartile range. And that's it. Okay, one more thing I want to talk to you about is how do we estimate the 80th or 90th percentile? Let's say the 90th percentile is what I want to estimate. I've showed you how to estimate the ogives, and I'm sorry, I estimate the quartiles, but how do I estimate, let's say the 90th percentile? So let's just remember what the 90th percentile is. We call it P90. But in order to find P90, you have to first find the position of P90. The good news is it has a formula just like all the others. So what is the position of the 90th percentile going to be? What is going to be the position of the 90th percentile? And then we will estimate P90 after that. So we know that it's really just going to be 90 over 100 times 91. So what do we get for that? 81.9, 82. So it's about the 82nd position. Now, you need to go to the 82nd position on the vertical axis, and you need to generate me an estimate of what P90 is going to be. What do you think it's going to be? Where's 82? 82 is about there. What do you think you're going to get? I'll put P90 there. What is your estimate for P90 going to be? So if I look where it's landed between 115 and 120, and it looks a little bit closer to 115. So I'm going to say 117 centimeters. And I'll even just, I noticed here I haven't put height in centimeters on the axis. Okay, last question of the day. I want to know how many students are taller than 117 centimeters. So this data table describes the height of the students in the class. I want to know, using the ogive graph, how many students are taller than 117 centimeters, approximately. It's an estimate, but this is what's called an interpretation question. Can you work out for me? We did one like it earlier. How many students are taller than 117 centimeters in your data set? What do we think the answer to that is going to be? So where was 117? 117 was the value of P90. So I'll give you a hint. You have to trace 117 back to the vertical axis. And what is that in line with on the vertical axis? It looks to me like it's in line with, well, 82, but that makes sense because that's where it came from. Now, if we know that 82 students were shorter than 117, how many students are taller than 117 centimeters? How many were there in total? Do you know how many there were in total? Do you know how many were shorter than 117? What's left? I'll wait for some answers in the chat before I explain it. So I know that I have 90 students in total in the table of data. I know that P90 is 117, and so that means that all the students who are below 117 or on 117, there are 82 students up to that point. Now, if there are 82 students who are shorter or the same height as 117, how many are taller? Well, it's just going to be 90 minus 82, which is 8. And so 8 students are taller than 117 centimeters. That is tricky, I know, but just give me a thumbs up or happy face if that made sense to you after I explained it.